Okay, so today we're going to be learning permutations for our extension 1 lesson today. Let's start off with an example to illustrate what that is. Okay, so example 8, it says 13 cards are chosen at random from 20 cards without replacement. Find the possible number of ways the cards can be chosen. Okay, so with this question, because you're choosing 13 cards, I've drawn 13 spaces here, and let's do this question like we usually do. If there are 13 cards, there are 13 spaces. So that means for our first pick, we have 20 cards to choose from. And then once we pick a card for the second card, I have 19 cards to choose from, and so on. So let me fill out all these spaces. So what you'll notice the difference between this and what we did last lesson is we don't have 20 times 19 all the way down to 1. We actually stop at a certain point because we only have 13 cards or 13 spaces to choose from. So my question is, instead of having to type all of this in the calculator, is there a way to express all of this as a factorial? And there is. Let's write it this way. What if I did 20 factorial, which is 20 times 19 all the way down to 1, divided by, if I divided it by 7 factorial, okay? Would that work? Because the top is 20 times 19 times 18 times all the way down to 3 times 2 times 1, divided by 7 factorial is 7 times 6 times 5 times, I'll just write the rest actually. Yeah, that's 7 factorial. If I divide that by that, I should have written a few more here. So 4 times 5 times 6 times 7 times 8, ... This divided by this, as you can see, if I cancel them out, that gives me the expression that I have here. But as you can see, that's quite tricky and time consuming. Oh, by the way, if you put this in the calculator, you're going to get 4.8 times 10 to the power 14. So that's the number of ways you can choose 13 cards from a deck of 20 cards. Instead of having to write it like that, girls, this is the same thing as writing 20p or permutation 13. Okay? The way this works, 20 is the total number of cards or objects that you can choose from, and 13 is the number of spaces or the number of cards you're choosing in this case. Okay? So think of this as spaces. So in order to type that in the calculator, you type in 20, shift the multiplication button, 13, and you'll see in the calculator 20p 13, and you'll get the same number, 4.8 times 10 to the power 14. Okay, so this is what permutation is. It allows you to calculate the number of ways which you can arrange things, given that you have to pick out a certain number from it. So in this case, the number of arranging 13 objects from 20 objects without repetition. And by factorial expression, that's the formula for permutation. Okay, so in our case, we had n, which is our 20 objects, factorial, over n minus r is the difference between 20 cards and the 13 cards to choose. So that's 20 take away 13 factorial. And as we can see, that's 20 factorial over 20 take away 13, which is 7 factorial, which is exactly what we had here. All right, so that's what permutation is. So now let's apply that in different examples. Let's have a look at example 9. It says find the number of arrangements of 3 digits that can be formed using the digits 0 to 9 if each digit can be used only once. So we need to come up with how many 3 digits we can form using the number 0 to 9. So I've drawn 3 spaces here, okay? And as usual, because we've got the number 0 to 9, that's 10 digits. So we can use any of the 10 digits for the first digit. And then once you've used 1, there's 9 left for the second one, and so on, okay? This is the same thing as writing 10p3. Again, 10 for the total number of digits you can choose from, and 3 for the number of spaces. Okay? So either way, if you type either of them in the calculator, you'll get ways. Okay? Now let's have a look at the next question with some restriction. It says how many 3-digit numbers greater than 700 can be formed. So if it's greater than 700, the first number can start with 7 because 700 and something is greater than 700. You can also have the first number starting with 8 because that will be in the 800s, and then 9 for the 900s. Okay, so that means, let's have a look at this first scenario. That means the number 7 is locked in from the digits 0 to 9, which means for the second digit, from the options, we now have 9 digits left to choose from. Yep, because we've used one from 0 to 9, in this case 7. And then for the third digit, then we'll have 8 numbers to choose from. So that's 9 times 8 options available that you can have that starts with 7. That's the same thing here then. In this scenario, if we start with 8, once again then, once 8 is used, I only have 9 digits available to use, and so on. And same thing for this one as well. So that means the total number of ways in which greater than 700 can be formed is 9 times 8 times 3 cases, 3. Okay? Or the permutation symbol would be, how would I write that as a permutation? Well, that is the same thing as writing 9 because you've got 9 digits to choose from and 2 spaces. Okay? And because there are 3 cases, you would write 3 times that. So this is the same thing as that, which is equal to, so that's a 2, 216 ways. Okay? So you can do the question either way, but permutation can help in certain situations. Okay, now we're going to look at a specific scenario with permutations that involves arranging the number of people in a circular table. But before we do, let's go back to arranging the number of ways if they're seated in a row. So in this example, if I want to know the number of ways to arrange 4 people seated in a row, as we learned from last lesson, the first spot can be occupied by any of the 4 people, so that's 4 times by 3 because the first person's taken up, times 2 times 1, and we learned this is 4 factorial. I won't write the number, it doesn't matter. So the number of ways to arrange people sitting in a row would be that, but it's slightly different when it comes to arranging people in a circular table, okay? And here's how you do it, and I'll explain why. What you do, let's say the first person is called A, you lock the first person in any of the spots, let's say that one. That leaves 3 spots available. So the answer to how many ways you can arrange 4 people in a circular table is actually 3 times 2 times 1, or just 3 factorial. Okay? So in other words, because let's say my people were A, B, C, D. The person A has been locked in one of the spots. That leaves 3 people to choose from. So let's say in here we've got 3 people that can sit in this spot. Once you've filled up this spot, now we've got 2 people for this spot and only 1 person for this spot. So the number of ways of arranging 3 other spots once the first person is locked in is 3 times 2 times 1. And here's the reason why you lock in one person first when it comes to circular table. Let's say the person A sits here, B sits here, C sits here, D sits here. Isn't this the same arrangement as if I had person A here, B here, C here, and D here? Aren't these two the same? Because A is directly on the other side of the table as D, and B and C are right next to A. In this situation, likewise, A is sitting directly opposite to D and is also next to B and C. Okay? These two are actually the same thing, because when it comes to sitting in a circular table, wherever the first person sits, it doesn't affect other people's position. There is no such thing as first spot or second spot like in a circular table. Okay? In a circle, it's just all about who you're facing. Whereas here, when we have people sat in a row, I can't do that because let's say I locked in the person A in this second spot. The second spot actually matters when it comes to the row, okay? Whereas when it comes to circular table, there is no such thing as a certain spot. So there's more arrangements. So I could still have, okay? So these are all the same arrangements, okay? So to avoid that, you always lock the first person in and then you just calculate the number of ways where the other remaining people can be seated, okay? Whereas, like I said, you can't do that when it comes to people sitting in a row because the position actually matters because it's in a row, okay? So that's the technique. So let's apply that technique in one of our examples. Let's have a look at question 18 in your actual exercise. It says a group of 7 people sit around the table. In how many ways can they be arranged with no restrictions? So once again, if you've got 7 people, you lock one spot in, and it's just a matter of how many can you arrange the rest of the other people, and that's 6 other people. So that's the 6 factorial ways. Okay? However, let's have a look at the next question. 18b, if 2 people want to sit together. So let's say these 2 people need to sit together. Think of these 2 people together as one person locked in. That leaves the rest of these other people that needs to be arranged. So that's 1, 2, 3, 4, 5. So that's actually 5 factorial. Now you've got to also times by 2 factorial because that's the number of ways within these 2 people can be seated. Okay? Okay, so keep that in mind. So when it comes to circular table, you always got to lock in one person or one group of people that are sitting together. Now let's have a look at question C. How many ways can there be arranged if 2 people cannot sit together? That's actually just the opposite of 2 people sitting together. So all you do is just the total number of ways, take away that. Okay, so that's your trick. Right. Okay, now let's have a look at question 19a, where we are going to look at people sitting in a row now. A group of 5 boys and 5 girls line up outside a cinema. In how many ways can they be arranged with no restriction? Okay, so if it says no restriction, we have 5 boys and 5 girls. That means there are 10 people that can be arranged within 10 spots. So that's just our usual question. It's just 10 times 9 times 8 times so on. So that's just 10 factorial ways. Okay. Now let's have a look at the second part. If a particular girl stands in line first, so that means one of the girls has to be locked in first. That leaves 5 boys and 4 girls. So that's just 9 times 8 times 7 times 6 and so onwards. So that'll just be 9 factorial, which is... Now, this is a question that I really wanted to show. Question C. If boys and girls alternate with either girl or boy in first place. Okay, I've drawn 2 sets of lines here because you can get 2 scenarios. Let's say in this case, the boy is first. That means we can have boy, girl, I'll just keep going. So this is one scenario. The second scenario is obviously girl being first. So girl, boy. Okay, now here's the way you look at this question. Let's focus on one of the groups. So let's look at boys. So we obviously have 5 boys, okay? The question you ask yourself is how many ways can these 5 boys be arranged in 5 spots? It's 5 factorial ways, isn't it? Okay, so that's the number of ways in which these boys can be rearranged. Same thing goes for girls. We have 5 girls with 5 spaces. How many ways can the 5 girls be arranged? 5 factorial ways as well. So what you do is you just simply multiply them together. Okay, that's the number of ways boys and girls could be seated alternatively. Now, because there are 2 cases, you get that number and then you times by 2. Okay, so that's how you do this question. 0, 0 ways. Okay, so that's the technique when it says alternate seating. All right. Now, let's have a look at another scenario when it comes to permutation and repetition. So the question is, how many ways can you arrange the letters A, B, C? Okay, it's a pretty simple question to start off with. So we've got 3 letters, so obviously that'll just be 3 times 2 times 1, okay, which is 6 ways. Now, for the sake of the demonstration, I'd like to actually list all the possibilities out. We can have A, C, A, B. So as you can see, that's 1, 2, 3, 4, 5, 6 ways, okay? But the question is, what if it was AAC? So we had a repeating letter. Let's list it out. So we can have AAC, we can have ACA, and we also can have CAA. Is there any other ways? No, so it's just 3 ways. So this is a pretty simple example, but what if we had a really long letter with lots of repetitions? So here's how you do it. So because there are 3 letters, okay, remember this was 3 factorial ways. So you still write 3 factorials, but you divide by, because there are 2 repeated letters, you divide by 2 factorial. That's the technique. Because 2 factorial is the number of ways in which these 2 letters can be rearranged. Okay, so let's apply an example 11. Oh, and by the way, so if you put this in the calculator, that's going to give you 3 in the calculator. So how many ways can you rearrange the words Uladula? So as you can see, there are lots of repeated letters. Okay, so firstly, count how many letters there are all together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, so that's 9 factorial on top. Now, we also have 1, 2, 3, 4 L's. Because that's 4 letters, you divide by 4 factorial for the U's. Okay, so that's for the U. We also have 2 U's, so that can be arranged 2 different ways. That's for, that's for the L's, that's for the U's. And is there any other repeated letters? Yes, we also have A's, so divide by another 2 factorial. Okay, that will eliminate the number of ways which repeated letters can be arranged. So if you put all of this in the calculator, you'll get this. Okay, so that's how you calculate the number of ways if there are repeated letters.